In this problem, we're asked about a double for loop that looks much like the other for loops that we've covered before. I have it highlighted here, and I'll copy and paste this into MATLAB. And the question is what's going to happen when you execute this? Well, it looks about the same as we've dealt with before. The only difference is instead of having a number like 4 or 3, we have a j here. But we can follow the same set of rules that we used previously to figure out what's going on. So this is between this top and bottom for and end, we need to repeat what's highlighted 3 times. Once for j equal to 1, once for j equal to 2, and once for 3. So I'll do that. J is equal to 1, j is equal to 2, j is equal to 3. Put this in here, here, and here. And then I'm going to follow the rules that we learned before, which were that we just need to expand this out. Now in this case, we're doing for I is equal to 1 to whatever the last value of j was. J is 1. So we're just going to do this once. At this point, we have j is equal to 2, and now we're going to repeat I in steps of 1 from 1 to the last value of j, which was 2. And here, similarly, j is equal to 3. And so another way of writing this is just to plug in numbers. J is equal to 1, j is equal to 2, j is equal to 3. And now it looks much like what we've had before. We know how to expand out this inner for loop. So I'll delete this and say I is equal to 1. And this is going to be done twice. Once for I is equal to 1, and once for I equal to 2. And this will be done 3 times. One, two, three, and 1, 2, 1. And now we're ready to just plug in numbers as we've done before. We can just do m of 1, 1 is equal to last value of I, which was 1. M of 1, comma 2, last value of I was 1. M of 2, comma 2 is equal to last value of I, which is 2. And here we have m of row 1, column 3 is equal to I, which is 1. And m of row 2, column 3 is equal to 2. And m of 3, comma j, which is 3, is equal to I, which is 3. So what this is doing is saying row 1, column 1, put a 1. Row 1, column 2, put a 1. And then row 2, column 2, put a 2. So if we look at what's happening each step along the way, that first line puts a 1 here. This line puts a 1 here. This third line puts a 2 at row 2, column 2. So nothing here, puts a 2 there. And then this fourth line says I'm going to modify row 1, column 3 and put a 1 there. And then here I'm going to put in row 2, column 3 a 2. Row 2, column 3 a 2. And then here a row 3, column 3 a 3. And as I noted before, when we don't specify what we want in a matrix, MATLAB assumes you wanted a 0. And so after execution, what you'll see is that you have zeros down here. And so to answer the question, which is what is M33 and M32? 33 is 3, and 32 is 0. Now let's look at a few ways we can modify this program. We can do a couple of things. One is we can ask what happens if we reverse I and j. And you can make this j, for example. And the process by which you would go about solving this would be similar. And again, what I suggest is that you make this modification, try to figure out what it's going to do, and then you execute it. And so in this case, we've changed this and we've changed this. And so down here, we would just have to change this to be j comma I and this to be j. And then we would have to update this right-hand side. And we would have to repeat that all the way down here. So that's one modification that you can make. Another modification that you should try is, let's do I comma j as before. Make this j. But suppose I said, start at j, go in steps of 1, and stop at, say, 5. What would happen in this case? Well, at this point, you would have the first value of I, so you would have j here. I'll write out the first line. You would have this. For I is equal to j to 5. Okay, if I want to write this out longhand, I need a value for j, so I'm going to put that in here, 1 to 5. And when I have j is equal to 2, I want to do this. Now j is 2, and I know how to expand this out. There are going to be one less number of steps in this case than in this case, because here we're going from 1 to 5, here we're going from 2 to 5. And then I repeat that process for j is equal to 3. And because this is originally j, I need to replace this with j is equal to 3. So it looks like in this last case we're going to do steps of I, starting with 3 and ending at 5. So this is going to be 3 times we're modifying this matrix. In this case, we'll modify this matrix when I is equal to 2, 3, 4, and 5. So that's 4 times. And in this case, we're going to modify the matrix 5 times, once for each value of I. And I'll let you plug in numbers and then check your answer on your own. And similar problems are, you can do for I is equal to 1 to, for I is equal to j to, say, j in steps of, say, -1 to 1 is another possibility. And we had 1 to j here. And suppose I came up with a problem where I did something like this. Well, in this case, we're doing clear, and then we're saying do j for j is equal to 1 in steps of 1 through I. But I has not been defined, so this is not a valid program. So in this case, we always have to have a number up here. But again, the point of this problem is to show that once you know the pattern, you expand out the loops and you substitute in numbers, you can solve pretty complicated problems, or seemingly complicated problems. This 1 to j looks complicated, but again, all you need to know is the basic rules.